That brings us to current day cryptography. The current standard is the Advanced Encryption Standard AES from 2001. One of the important lessons learned with the experience from DES was that eventually computers will be fast enough to brute force a particular key size. For that reason, AES was designed to be able to accept more than one length of key. And the idea is that over time, as computers to break the encryption get faster, you can just use a bigger key size to make brute force attacks of trying all possible keys computationally unaffordable. So baseline DES breaks the data to be encrypted into 128-bit blocks and uses a secret key of 128 bits. But over time, as computers have become faster, people have shifted from 128-bit keys to 192-bit keys or even 256-bit keys. So when you say AES-256, that means AES with a 256-bit key. Note that as you double the number of bits, you need exponentially more computer power to use a brute force attack because a 256-bit key is not twice the number of keys as a 128-bit key, but rather it's 2 to the 128th times more possible keys. The precise details aren't super important for our purposes, but let's take a quick tour of how AES works. It first substitutes some byte values. It then shifts the rows of bytes. It then multiplies each column by a matrix using mixed columns. These are all steps that provide confusion and diffusion. Finally, it XORs the result with a secret key, and that's the piece you need to be able to reverse the process. As far as we know, AES is still okay as long as you use a big enough key size.